Okay, so I think that's my cue to start talking. So just before I get started, is there anyone in here who needs this talk to be in English? There was a hand. Okay, cool. Let's do it in English. That is fine, not a problem at all. I just feel stupid to do it in English if everybody is Swedish speaking. You're in the room where I'm going to talk about integration testing, ASP.NET Core, and the basics around that. If that wasn't the talk you wanted, then sucks for you, the door is closed. So, my name is Klug. I work at a company called Active Solution in Stockholm, where I do what I get paid for. And I say that in the loosest terms because I do a lot of different things, but mainly I do software development. I've been doing .NET development since the inception of .NET. I've been doing software development in general since about 98 or something like that, so it's been a few years now. And then on the side, I do public speaking at conferences and try to share knowledge and things I've learned along the way. So we're going to be talking about automated testing today, or integration testing in specific, but integration testing is a part of automated testing. But before we do that, we kind of need to go and it's like, why do we automate tests at all? Why do we write automated tests? And there are a few different reasons that we can agree on or disagree on whether or not they are a good reason. First one is often to find bugs. Yes, I think you do find bugs, especially with integration tests. For unit tests, I disagree much more for the very simple reason that if you're smart enough and realize enough about your code to be able to write the unit test that finds the bug, then you have probably already written the code that solves that bug for you, in my opinion at least. For integration testing, we do find bugs quite often because it tests bigger parts and we find the jagged edges where things don't fit together properly. Documentation, that is a really good idea and a reason on paper. In the real world, sorry to say, it's really not that great. Let's do a show of hands. How many of you go into your test suite to take a look at how something works? How many of you go into your code and look at the code to see how it works? Yep, exactly. So 4 people go into the test suite and the rest of the room goes into the code, and that's the way it works, which is why documentation to me isn't quite a valid point, even though it's a really good idea and I really like it. And if you do want to go down this route, have a look at how to name your tests and all of that stuff to actually make it as good documentation. But this is the one that makes it for me. Being able to run parts of my application quickly. Being able to go in and say, I'm working on this little piece of code, run that piece of code for me and verify that it does what it's supposed to do without having to do, let's see how many of you recognize this. Write a piece of code, press F5, go into your website, find this form that you're looking at, then fill out the form with some dummy data, press next or submit, have a breakpoint that you jump into, then there's a loop in there and you have to go F5 4 times because the 5th time is too late. And when you press submit and you jump into the breakpoint, you realize, oh, I should have selected that other thing over here, and then you have to break your test and restart. Anybody recognize the scenario? Because that's been my life for the last 20 years. Now, having my tests, I honestly don't run the application basically anytime. Right now, I'm working on a project where I write the back end. I have a colleague of mine writing the front end. I've never started the front end on my machine. I run and exercise my entire API from my integration tests without having to ever run my application, which is really so much faster and so much easier to work with. But we also have different tests for different reasons. And I think all of us have seen the fantastic pyramid that everybody talks about, the testing pyramid, right? And the testing pyramid says that we should have lots of unit tests, fewer integration tests, and a few end-to-end tests at the top. Now, before I go into what I think about this pyramid here, let's just define what the different levels are, what an integration test is, what a unit test is, and what an end-to-end test is. And honestly, we are not going to define anything. I'm going to tell you what my definition is because I don't care about yours. That's not quite true. But for this talk, if you understand my definition, it makes it a lot easier because then you understand what I'm saying. If you disagree with my definition, you're more than welcome to. Unit tests. Test the smallest part you can test, basically testing one class or even one method on a specific class. It's a tiny little thing that tests the specific functionality of that tiny little piece. Integration tests, as soon as you start combining multiple pieces, you start combining multiple classes into a test, it becomes an integration test because it integrates two classes. And an end-to-end test is something that tests the system from basically the front end all the way down to the database. That would be my definition. Then there are definitions of this depending on, are you building a UI? Is the UI included in end-to-end? Are you building an API? Is the API your UI? Let's just leave that out there. Let's call it an end-to-end test. So this pyramid here says that we should have lots of unit tests, fewer integration tests, and just a tiny bit amount of end-to-end tests. Now, the problem I have with the testing pyramid is the very simple fact that the value proposition of the testing pyramid is inverse. The value of a unit test is almost nothing, and the value of an end-to-end test is worth a whole lot, at least to me, because I know when I go up to my end-to-end tests, if they run, it means that every piece of code from my UI all the way down to the database is built in a way that they actually work, and they work together, and they perform the task that they're supposed to perform. Whereas if you go and take a unit test, the unit test tests a very specific thing, and it doesn't see whether or not it works together with anything else. And then, why do I think it looks like this? Well, for the very simple reason that end-to-end tests are really hard and expensive to maintain. They often change over time, the UI changes, they're often quite flaky if you're running something like Cypress or Playwright is better, but they're all building on the idea that you spin up a browser and the browser can hang and all that. So the further up the pyramid you go, the harder the tests are to maintain, the flakier they can be, and the more it costs to actually hold them or run them and maintain them. Whereas a unit test has barely any cost whatsoever. It takes 0 time to write, 0 time to run, and it gives you a bit of value. So there's a reason for the test pyramid. But the problem is that if you only run unit tests and you don't run integration tests, systems don't work. So if you just run unit tests and you don't run integration tests, your systems don't really work, do they? Or if you, once again, you just run unit tests and then don't run your integration tests, they do work, but not the way you want them to work. Or another one of my favorite ones, let's put the air dryer right above the, each individual piece works, right? Or if you just run unit tests and not integration, you get my point, right? Each individual piece would pass a unit test, or a bunch of unit tests in this case, but once you put them together, it fails. So yeah, the reason for the testing pyramid is this, basically. That every test gets smaller, and the cost of running them gets higher in those directions, and that's why you have that pyramid. What I'm going to be talking about today is API testing. So API testing is nice because it doesn't include a web UI, which is complicated to test. But if we look at the pyramid, personally, I would say that we end up here. It's going to be an integration test because it's going to be all the way. You could also argue that it would be an end-to-end test because the API API endpoint or the endpoints are basically my UI into my application. So it is an end-to-end if you don't want to include the front-end React app that my colleague is working. But let's just agree that I'm somewhere up here in what we're testing today, or what I'm showing. So the question is then, wouldn't that be really slow and fragile? If we look at the testing pyramid, if I'm that far up, everything is telling us that that's going to be slow, and it's going to be hard to maintain, and it's going to cost a bunch of money, and no, it doesn't. It used to. It doesn't do that anymore because there are frameworks that can help you make that easier. However, there are a couple of problems that we need to take into account when we do want to test our APIs. And we have the thing that your tests need to be able to run without a special environment. You shouldn't need to have a test environment that is somewhere over here that is separate from everything else, and you write your code, and then you deploy your code to the test environment, and then you run your tests on your test environment, and then you get the response back. That's not the way I want to do it, because that takes forever. I want to get my code information back continuously. I want to be able to run my tests every 20 seconds while I'm developing to see if it works or not. So it needs to run without a special environment. We need to figure out how to handle dependencies. Dependencies can be a lot of things. It could be the database is a dependency. I want to include that dependency. But you might have third-party dependencies where you're using other APIs or other services that isn't possible for you to run in your tests because they cost every time you call them, or they don't have a test environment for you to call and things like that. So those dependencies need to be able to be faked or mocked or stubbed or whatever you want to do. Authentication, I think that should be a part of it as well. I have seen people go, oh no, I test everything, but authentication is hard. So we have a flag that says, if development environment, don't add authentication. And it's like, isn't authentication a part of what you want to validate with your API? For me, that is a very big part of what I want to validate as well. So we want to have authentication in place as well. And then coming back to the conversation, the database. Database is always the problematic part in my opinion because there are ways to handle the database, but they're all cumbersome in some way. We could have and spin up a new database for every test. We could try and use the same database for all the tests, or we can mock out the database. And mocking out the database or removing it, or does anybody use the in-memory entity framework provider? So I think that is being removed or deprecated because it doesn't actually work. Because it doesn't actually go and check your bindings for your objects, and it just stores it in memory. So things you can do with that provider doesn't actually work with the SQL provider. So you're not, or whatever other provider you have. So it means that if you run that, you can't actually verify that your code really works because it might fail talking to the database, for example. There are lots of different ways to handle that. I'm going to show you my way, but there are other ones. Just keep in mind that it's not as simple as to say we're going to have a database with test data and we're going to run all our tests against that, because once you start doing updates or adds, your test data is now going to change over time, and then you're going to end up with your test starts failing over time, or even worse, they start failing mid your test run, because if the tests aren't running in a very specific order, they will actually fail because the data changes over time and things like that. It's a pain in the butt. Anyway. Code. Much more interesting than just seeing me with an orange slide. So let's go ahead and write some code. Let's see if the people in the back can see this. Can the people in the back see that? No. Let's go and say, how do you zoom this? You zoom down here, right? So let's see, is 150% good enough for the old people in the back? Even Mike Martin nods, so it's definitely big enough. Okay. So this is my application. This is not impressive in any way whatsoever, but that's not the important part. The application doesn't matter. It's a very simple ASP.NET Core application. It currently has a single hello world endpoint using minimal APIs. I have some other stuff up here that I will come back to later on when I make the API slightly more complicated. But it's basically a very, very simple web API. And down here I have an XUnit test project. It's basically brand new test project, except for the fact that I renamed it from class 1 to home tests, and I added a test called get returns hello world, which is what the test is going to test. It's going to test that a get to the endpoint returns hello world. So to be able to test this, I'm going to need some form of web server, something that can respond to HTTP calls, and Microsoft has been nice enough to add a NuGet package for us that we can use. And I just had a conversation about this earlier today. It is named incorrectly. It is called ASP.NET Core MVC. Testing. So it's Microsoft ASP.NET Core MVC testing. It has nothing to do with MVC. It has to do with ASP.NET Core and testing, so just ignore that it says MVC because it works on anything that you plug into the request pipeline. So it's fine for us even though we're doing minimal APIs in this case. So I installed that little NuGet package, and then we can start implementing our code. So to run our application and get something that we can call using an HTTP client to see that it works, we are going to go and add what is called a web application factory. So a web application factory creates an in-memory representation of your web server and your application. First thing that happens now, though, is that we get a red little squiggly. And it says, if we look at it, it says, program is inaccessible due to its protection level. So true, also a very bad error message because it's hard to understand what it means. What it means is that you can't access this class because it's using top-level statements, and that generates a class under the hood when you build it. And to get around it, you basically do public partial class program like that. And then you go back to your test, and the red squiggly disappears. So that's the first part of getting started with testing, is you need a public partial class thingy at the bottom of your program file. Now, after that, we can go ahead and add a piece of code that looks like that. We're going to make this async. So what we get is the web application factory will start up our application or web app defined in the program class, and it will create a client for us. And this client here, if we look at it, is actually an HTTP client, but it doesn't actually use HTTP at all. It goes in and it changes some handlers and things like that, so it doesn't run over a port and start a web server on your machine, but it basically emulates a web server for you in a nice way. And then you can just go await client, get async, and say, hey, I want to call this thing here. So that's the first part of my test, setting it up and performing the thing that I want to test. And then we can do a little assertion here at the end to say, hey, did I get a HTTP status OK back? And did I get the hello world that my API sends back here? Now, with that in place, I should be able to go to my test explorer. It finds my test. I should be able to expand that. And I should be able to go and run my test. And hopefully that goes green. And but Chris, you said it was going to be fast to run these tests. Yes, it is normally fast, but I have a shit computer that is really slow. And also, for some reason, it is really slow the first time you run it. Every following thing runs quite quickly, but the first one does take some time. But the actual duration of the test is less than a second to run this one test. And then when you start running more of them, they don't take a second each. They take like milliseconds per test. So it's actually quite good. Okay, so now we have our first test. We obviously need something else to test, a bit more complex than returns hello world, because even though we build really boring applications in our lives most of the time, they are more interesting than that. So I'm going to go and add another endpoint in here, and it's going to be /chuckquote. And at this endpoint, I'm going to use my iChuckQuotes provider to get Chuck Norris quotes. And the iChuckQuotes provider implementation uses the Chuck Norris API to get jokes about Chuck Norris, and it basically calls out to a separate service. That is obviously going to cause some problems in my tests, because if we keep running these tests over and over and over again, the Chuck Norris API owners are going to get really annoyed by us and block us or something like that. But it's a very simple endpoint. It does illustrate the point of having a third-party dependency that we want to work with. And for that, I'm going to go and add another test class. So we're going to go add class. I'm going to call it Chuck quote tests. Chuck quote test. That's spelled quite okay. And then we replace that with something that looks like that. So it's basically just all I did was remove stuff I didn't need and named it get returns a quote. So I like prefixing all of my API tests with like get, post, put, so it's easy to see what HTTP verb am I working with. So when you start looking at the tests in your test explorer, they kind of make sense. A whole different conversation about how to do the thing to get the structure properly. That's another talk some other day. Now that I have that, let's go and add kind of the same thing I had before. I create a web application factory based on my program. I create a client. I call the getAsync method, passing in Chuck quote to make the call. I look at the status code. Now the problem here comes down, how do I do a test that verifies that I get something back that comes from a random third-party system? That's obviously going to cause some problems. So we are going to have to go and fake that dependency in some way. Now, luckily, on this web application factory class, there is a method called with web host builder, which allows you to plug in to the builder, like the thing that sets up your host. So it allows you to go in and modify the things that is happening inside your program CS file. And inside that class, or inside that, we get the builder, and the builder actually has a method called configure test services. which gives us access to the service collection after the program CS has added its stuff to the container. So basically we can go into the services collection and make modifications to it. So everything that program CS put in there is here now, but then I can go and say, I want to replace that one and that one and that one for my test. So in this case, I'm going to need another iChuck quotes provider. And the easiest way to do that is by mocking it or faking it in some way. So I'm going to put in a little framework called Fake It Easy. And you can use whatever mocking tool you want. I just, for some reason, like the syntax of Fake It Easy, so it's my go-to whenever I do mocks and fakes. So I got that installed. And that means that inside this configure test services, I can now go ahead and create something that looks like this. So I create a chuck fake. It's a fake of type chuck quotes provider. I tell it that, hey, a call to get quote returns Chuck Norris can dribble a bowling ball. And then I tell it, hey, I want to put that in as a singleton, and that's going to overwrite the previous registration of iChuck quotes provider for this test. And if we go back to my test explorer, it has now found my tests in here. And if I go and run that, it goes green. So that test works as well. So we can go in and just replace whatever services we want, which is a really powerful way to do it because you can do so many things with that. But we also need to remember one thing when it comes to integration testing, or testing in general. You cannot just go and do happy case testing. We can't just test that it works. We have to test that it doesn't work as well. So let's go and put in a test that looks pretty much exactly the same as this, but it looks to see, hey, what happens if there is a problem with the call. I expect there to be like an internal server error message coming back, and I expect it to write API was not strong enough to joke about Chuck as a response as well. And once again, what I need to do is I'm going to have to go in and replace that with a fake as well. But in this case, I create a Chuck fake, but instead of saying Chuck quote return something, I just go and say, hey, throw an exception. You could be way more specific and throw specific exceptions and all of that stuff. All I wanted for this is just don't show that you shouldn't forget to test what happens when shit hits the fan and stuff doesn't work, because that is going to happen. I see way too many people writing tests and they just test all of the happy cases and they go, works perfectly, and then they deploy it and something breaks and the whole thing just breaks down and everybody starts crying because they didn't know that was an issue. Okay, so now we've got some tests for the Chuck quotes. What happens if my client now comes and says, Chris, you have a very beautiful API, but we obviously want to charge people for this because this service is obviously worth money. So we're going to need authentication on this so we can start charging people to sign up for this. So when we do that, we go in and we say builder dot, actually I have a snippet for it, look at that. Let's just use that, that's easier. So I'm going to go in and say add authentication, and I'm going to add bearer token authentication. I don't know why I have two, so it's authentication, sorry, and authorization down here. And then I'm going to go in here let's see where I want to have this. I want to have it on that dot require authorization to say that I want to have authorization for this endpoint. So if you're not authorized, you can't access it. Now, for those of you who know authentication, ASP.NET Core, you're going to look at this and say, but Chris, you haven't actually configured anything in here. It doesn't work. No, it doesn't. You can't log into this system, but it will verify authentication. So if I run my test now, it will say that I'm not authenticated. That's kind of all I need. I don't really care about how you do the authentication. What I care about in this case is that there is authentication, even though it's not fully configured. And as you can see, my errors now go, and instead of OK, I have unauthorized, and instead of internal server error, I have unauthorized. So how do we do checks or integration tests with authentication in place? And there are a few different ways. Being that so most people today use bearer token authentication or cookie authentication. Both of them have kind of a problem. It means that somebody needs to go and figure out a cookie or a bearer token that is valid during your test specifically, and that can be a bit complicated because you don't want to use the production settings and blah, blah, blah. It becomes a whole thing. So my solution to that is a little bit different. So I'm going to go here. I'm going to go to my chuck tests again. They're obviously failing. I'm going to do a little bit of cleanup because there's a bit too much repetition in here for my liking. So I'm going to go and say, I have a method here called setup. It returns an HTTP client. It takes a callback that allows me to configure my iChuck quotes provider, and then it sets up my factory for me, which means that I can now replace the repetition up here. Actually, the repetition, let's start up here. I can replace this with something that looks cleaner, like that. And I can replace all of this with something that looks like that. So that becomes cleaner, easier to read, less repetition. Test only has the test part, and then the setup is actually down here. Now, the first thing I want to do before I start testing or figuring out the authentication part, I do want to have a test that just verifies that people do get unauthenticated, so unauthorized back. So I add a little extra test here that says get returns HTTP 401 if user is not authenticated, just to verify that that test runs, if we're going to go with the whole red, green, refactor, blah, blah, blah that people talks about. So it went green, so people are not being authenticated. We already knew that, that's fine. So partially it works now, but we still need to figure out how to do the authentication part here. And my solution to it is that I actually remove authentication partially. So instead of using the bearer token that's in my application right now, I'm going to trust that Microsoft has done the authentication system well enough that I can actually remove bearer authentication, plug in some other form of authentication, and that will be equally good as running the bearer thing, because the authentication part is actually separate from the actual request pipeline. So whether or not I'm doing basic authentication or I'm doing bearer token authentication, the actual pipeline will work the same. So because of that, I'm going to show you how I do it. I'm going to go and add a NuGet package that is called Bazinga. Bazinga ASP.NET Core Authentication Basic. Microsoft has, as far as I know, not provided us with an implementation of basic auth for web at all, for the very basic reason that it is crap, should not be used, and if you ever mention it to security people, they will laugh at you. So don't use this outside of your tests. Okay. I have that in place. What I'm going to do now is I'm going to go to my setup method down here, and I'm going to go ahead and add, let's do it down here, this code. Actually, nope. Wrong place. There it is. We want it here. So I'm going to go ahead and call services.add-authentication again. Remember, this has already been called in Program CS. But the fact that I call it again and I give it another value here saying that, hey, the default authentication scheme is now basic auth, means that I'm going to overwrite the default settings from my Program CS. So all of my tests will now be running basic authentication. Basic authentication is based on the idea that you check just the username and password like that. So this is now replacing authentication in my application. Now, most of my tests will be running authenticated because, well, that's the way we're going to test our API. So I'm actually going to add a little method here. Property called bool is authenticated equals true, because that's going to be the default. I don't know. Oh, nope. Sorry, wrong place. That's where we want it. And we want it at the end, like that. So, sorry, like that. So I add that, and then down here, before I return my client, I actually go in and say, hey, if you pass in is authenticated, I'm going to go and create a base64 encoded authentication string, which includes a base64 encoded version of test:/test, which is basic authentication, and I'm going to add an authorization header to your client. Basically, I'm going to make your HTTP call authenticated as long as you pass in is authenticated. And finally, I'm in my authentication thing here, I need to go in and say is authenticated false. Now, if I go to my Test Explorer, this should now verify that I am now authenticated, my API works, and it also works returning unauthenticated if you're not authenticated, and it goes green. So solution to authentication for me is basically replacing the built-in authentication, which is bearer token, which is complicated to do, with a very simple form of authentication. But as I said, all of these authentication providers do plug in to a provider model inside of ASP.NET Core, so it doesn't matter which provider you use, the request pipeline will still handle it in the same way. Okay, so that was a good start. But let's make our application a bit more complicated. I'm going to add another set of endpoints here. So I have a to-dos endpoint. The to-dos endpoint returns a list of to-dos. And there's also a patch endpoint where I can patch a specific to-do item and update the title and description is complete. Doesn't really matter. The important part about the I-to-do service is that the actual implementation of I-to-do service uses a to-dos DB context. So it uses entity framework to talk to a database. Now that ugly database is back in the room and we need to figure out how to do the databases. And I'm going to show you my way to do it. Even if you don't agree with it, it's a way at least. So to test that endpoint, I'm going to go and add a new test class in here. So I'm going to go to API tests, add class to-dos tests. That didn't come out very well at all. To-dos, that looks better. I'm going to replace it anyway, so it doesn't really matter. There it is. So I hate people who paste code in. I know, I'm sorry about that. I did just paste in a proper copy of the setup method that I had in the previous class as well. And I added a default test up here that says get returns HTTP 200. That's all I did. No, I do not recommend having a unique setup method that is identical in every single class. Get a base class, a helper class, or something like that. We'll get back to that. For now, I just want to have everything in one class or in one file because it's easier to work with. So now this thing makes a call to to-dos. It does it authenticated. It verifies that I get an OK back. If we run this test, it goes red. Now, why does it go red? Well, quite obviously because I have a database. But why does it go red? Well, if you start digging into my code, which I actually did the first time I ran it because I'm stupid, I figured out that inside of my app settings.json, there's actually no connection string, which means that you can't connect anywhere, so my database is not going to work at all. So I need to fix that. I don't want to go and add the connection string to app settings.json because that was going to be the one that's being used when you run the application, not while we test it. So what I'm going to go and do instead is I'm going to go to my setup method, and then I'm going to go ahead and add a piece of code here. So the builder has this configure app configuration, which allows us to configure the app configuration, like it's called. Which then, the app configuration is provider-based, once again, in ASP.NET Core, which allows us to add things like JSON files, ini files, environment variables, but it also allows us to do like add in-memory collection. So I can go and say, hey, add an in-memory collection thing here, like a dictionary, connection string, SQL, here is the connection string to my database. You can take as many pictures of you want of my secret password. It's on my local machine, so that's fine. And that gets injected, and now my database is going to find that connection string. So if I run my test now, it should get a database. And it, weirdly enough, goes green, which is not what it should be doing. I am sorry. I probably have an old test database laying around from a previous demo. Sorry about that. Give me 1 second just to kill that. Anybody know somebody on the SQL Server management team? Because this is the slowest piece of software I have ever worked with. So sorry, it did find a database, and that's kind of a problem in this case, because I wanted there not to be one. Databases, there, look at that, integration testing demo, delete. So just imagine that it is a minute and a half ago. I just added this stuff. You had not seen this, and I ran my tests. The test now just stands there, chugging. It's like nothing happens. So the reason for that is that it now has a connection string, but there's no database. There was a database a few seconds ago. There's no database anymore. So what we need to do is we need to get hold of a database with data in it, or at least a database with a structure in it. So my application, my data folder here actually has a migration that sets up the immensely complex database that I'm working with, which includes one table. That is what I want to use for my tests. So before every time you run your test suite, I want to go ahead and I want to run this piece of code that basically runs my migrations. And the way you do that in XUnit, or one of the ways you do that, is that you can go into and create. I'm just going to create a folder called infrastructure. That looks right. Then I'm going to add a simple class in here, a simple C# class, and I'm going to call it test run start. Then I'm going to replace all of that with something that looks like that. So what you do is you create a class that inherits from XUnit test framework, which allows you to basically plug into the startup of a test run. So when you press play down in the test explorer, it runs once, not for every test, but once every time you press the play button. And then this thing has a constructor where you can do your changes. And then you need to mark it with this assembly level attribute called test framework to say that, hey, here is a class that implements XUnit test framework. You should run that when you start your tests. Now inside here, I'm going to need a connection string to connect to my database. And I just made the fantastic, brilliant idea of hard coding my connection string into my test class here, which is bad in so many ways it's not even funny, because it causes problems when different developers have different ports and things like that. So to solve that, I'm going to go ahead and I'm going to go to my app settings.json up here. I'm going to copy the app settings.development.json. I'm going to name it app settings.integration-testing.json. I want to have a big T, capital T, because I am slightly OCD. I'm going to add connection strings, SQL. Now add my connection string in here. From that angle, you're going to get so much double chin on that picture, it's not even funny. Okay, so I put my connection string into this integration testing.json. And the cool thing is, since we're running the program CS file as usual, the convention in ASP.NET Core is that it reads in appsettings.json and appsettings.environmentName.json. So if I can get an environment name into my application called integration testing, it will actually automatically load that JSON file for me. So if I go to my test and we comment out this version here that we don't want to use really for this scenario, and instead say builder.useEnvironment, that was not what I wanted to do. Can you go away? Use environment integration testing. It will now automatically load that JSON file for me when I run my test as well. But now that I have a file, I can go back to my test run start and I can go and write something like that. Create a new configuration manager, add a JSON file called appsettings.integration.json, build it to get my actual configuration, and then finally create a DB context options builder for my DB context, give it my connection string, get a context, get the database on the context, and tell the database to migrate. One thing to note about this code here is that it swallows exceptions. It's really nice for you. Your tests go through, even though this code fails. But all of a sudden, your migrations haven't run, and you're wondering why your tests don't work, because this swallows your exceptions. So if you ever get problems with running your migrations, you do have to put a breakpoint in here, then run your test once in debug mode, and then when you get here, if you press F5, it's going to break, and it's going to tell you here is what went wrong, and then you can figure out why your migrations didn't work. Just a tip from the coach, because I might have lost a few minutes on that, or maybe more than a few minutes. So Now I have a thing that runs my migrations, connects to the database, runs my migrations. So if I go to my test explorer and we try to see if we run that now, see if we can find my tests again. It finds my tests. And it goes green. So what's happening now is like, I run my test, it goes to the test run start. The test run start gets my connection string from the app settings.integrationtesting.json. It runs the migrations. After the migrations is run, it comes back in here. It uses the helper here, web host builder thingy, to set the environment to make sure that it loads in the app settings.integrationtesting.json. And then when I run my test up here, it works because there's a database. Now this test here is maybe not the most successful test when it comes to verifying that my endpoint works. So let's go ahead and add this test. Returns a list of items. So simple here, get async, jarray parse, not empty. Now I also want to mention here that I use jarray.parse. I've heard quite a few people say, why don't you just do JSON convert.deserialize and you deserialize it to the thing that you're sending back from the application? If you do that, you're losing out. Because if you ever go and change the return type from your API, your test is automatically going to be updated with the new return type, right? Which means that you actually lose any form of backwards compatibility checks. If you do an actual JSON verification of your thing that comes back from the API instead, it means that in the future, when you go and modify the return type, if the new return type that you're using doesn't fit into the JSON object that the client actually expects based on the previous version, then it's going to break for you. Which is why I use this really annoying JArray and JObject syntax from James Newton King's JSON.NET stuff. Okay, so very simple. Is the array empty? Is the array not empty? That's my test here. I finds my tests, runs my tests, and it goes red. Now, it goes red because the collection is empty because I just ran my migration, so there's no data in the database. But I do not want to go and add data to the database in my test run start, because then I'm back into tests having to run in a specific order for them to work and have a specific data set that is actually big enough to support all the different test cases that I want to do and all of that. That's kind of a pain in the butt. So I have a way to solve that. Once again, this is my way. If you don't like it, there are other ways. But what I'm going to do is I'm going to change my setup here a little bit. I'm going to add an out. I'm going to out one of these. I'm going to out my web application here. Like that. And I'm going to remove the var here. And that is going to mean that I'm going to have to go in and say var, now out var up. I'm going to add out var up here. Like that. Now, what I'm going to do in here, right before get async in my returns list of items, I'm going to go ahead and I'm going to add a piece of code that looks like this. I'm going to explain this. I'm just going to collapse that. So what I do is, after I've set up my application, I use the app.services, basically my DI container, and I create a scope. Every incoming web request to your ASP.NET Core application will create a separate IOC container scope. That scope will contain all the services needed or used by that request. Then inside that scope, I go and I pull out the to-dos DB context. Then I begin a transaction on that DB context, basically saying that I have a separate transaction that I am in charge of, that anything that the DB context does into the database goes into this database transaction. Then I go and get the database connection. I create a database command. I add the transaction to my database command. I run the command text here to insert my to-dos that I want to use for my test. And then I execute the query async. And then after I've inserted my information into the database, I go and I run my test. And then finally, I do a transaction.rollback, which means that empty database, test comes up, inserts data needed for that specific test, run the test, rolls back data with the transaction. So it comes back and has an empty database after I'm done with this test as well. And being that it's all done in this way with a transaction, I can run my tests in parallel as well, because they all have individual transactions. The only thing you need to remember is that do not do enable identity insert on and start inserting your own IDs, because that ends up being bad. So if you are doing ID columns and things like that, make sure that you auto-generate the IDs in a nice way so it doesn't collide in your different applications or different tests. Now, if I run this, let's go ahead and run returns list of item, because now there's stuff in my database. So I run my test, everything looks good, and it goes red again. Anybody know why it goes red again? I did mention it. I told you that when you create a scope up here, I do that because I need to get hold of a scope in the IOC container to get my services. I also told you that every incoming request creates a new scope, which means that I just created a transaction and added database to a DB context in a scope over here, and then I run my test in a scope over here, which doesn't have that transaction, doesn't have that data. So I did cool stuff over here, and my transaction for my actual request was somewhere else. Now, that's actually fairly easy to fix. It might look weird. I totally agree. But it works. If we go into configure test services and we write services.add singleton, and then we do to do's DB context, like that. By default, in your program CS, when you do up here at the top, you say add DB context. Default implementation of DB context, if you don't pass in an extra parameter, marks your database context as being scoped. So a new one for each scope. I'm turning it into a singleton, and then people go, but Chris, you can't just take a scope thing and make it a singleton, because the application depends on it being scoped. Yes, if you're to run an application, it needs to be scoped, otherwise they're going to step on each other. But in our test, we're only going to make one call, right? So it doesn't matter if it's singleton or scope, there's still just going to be one instance for that specific test. So it's okay to turn it into a singleton in this case. And now that it is a singleton, I'm going to get the same to-do's DB context in my code here as the test will get. So if I run this test, it hopefully goes green. So it works. So now it's actually testing all the way. The only thing we need to do here at the end is not empty is not enough of a test. We actually do need to test something like, is there 2 items in my list, and are these the 2 titles that we have up here, and that works fine. We can also go and add a little extra test in here. We can go and add this thing here, which is a bit more complex. So it does a patch. So it sets it up, it creates the scope, creates the transaction, adds the data we want into the database, but I do a select scope identity to get the last inserted identity, so I know what to query. Then I do a patch as JSON to the to-dos/ID, and then say, hey, can you update this title here and that information to new title, new description, is complete equals true. And then I can go down here and I check the status code. I verify that I get the object back, but I also do this. Since I now have a transaction, a connection to the database and everything, I can just go and pull that command for that, or create a database command for that connection string, and then go and say, hey, can you go also and verify that after I ran this thing, the database actually looks the way that I expect it to do? So at the end here, I can go not only say that, okay, the API said, yes, it was okay, and returned a 200 and an object, I can also go in and verify that it actually went all the way down into the database to do it, and then once again, finally, I roll back. So this is kind of neat. The only thing I dislike about it at this point is that there's lots of code. There's lots of repetition. I've only got 2 tests. Imagine just repeating these several hundred times and then realizing that you need to make a change to it. It's going to be a pain in the butt. So this we can dry up a little bit. So what I'm going to do, and there are ways to do this. There are multiple ways to fix this. I'm going to do it like this. I'm going to change this here and change the syntax to look like that. I'm going to be a bit more functional. So I'm going to create a method called execute. It takes a func of HTTP client and task. It takes a func of DB command and task, func of DB command and task, and is authenticated, called execute, add test data, validate DB. going to change this thing to be a variable, like that. And then we're going to go ahead and somewhere down here, we're going to remove the client. We're going to add in a piece of code that looks like this. So I'm going to go ahead inside this method, I'm going to go and create that scope that I have been using before, and I'm going to go ahead and add my test data by going in and saying, hey, I need a DB context, transaction, DB connection, DB command, transaction, add test data, and then call add test data. So I'm going to call the callback method to add test data if that was provided. Running the actual test is just an await execute client. And finally, I can do the database check in the same way that I did before by just calling validate DB, because I already have the command in here. So if you did pass in a validate DB callback, I'm going to run that for you after the test. I'm now running out of time, so I'm just going to very, very quickly do this and show you how much cooler this actually looks when you're done with it. So if we do that, returns HTTP 200 now ends up with being just an execute async client. Here is my test. All done. All of this stuff here gets turned into that. Execute. You can see here, basically you can read the code that says add test data. This is what I'm doing for test data. Here is my actual test. Execute. And finally, the last thing down here can get replaced by something that looks like that, where you have add test data. In this case, I can't do it as a Lambda thingy. It has to be like an actual body, and it has execute. I save the scope identity to a variable out here, so I have add test data, execute, and validate DB. And normally when I do this, while this runs the test, I can just tell you, I add extension methods to CMD, so to the command here, so to SQL command. So when you look at the test, it says CMD, await CMD.add user, add process, add connection, add, so we can see everything that we add to the database in like a readable format. Then you run the test and you validate the database and you're good to go. And each test just becomes this, what data do you want in the database? How do you want to call the test? Do you want to validate the database afterwards? And it did go green, so I'm kind of happy with that. That is kind of all I had. The code for this is available if you're interested at that address. And I've also blogged a little bit about it on my blog, fearofoblivion.com. I haven't blogged anything for the last 2 years or something, but this is in there if you want to read more about it. Other than that, thank you all for listening. Please do an eval if you liked the talk. If you didn't, then tell me why. I'll explain why it was awesome, and then you eval it as a really good talk, and we're all happy. Thank you so much.